Hello my scholars, you're welcome to my school YouTube channel and my name is Frank. In today's video, we are moving to another main heading on our physics topic by topic video lesson. So in today's video, we'll be moving to field, and under field, we'll be looking at the description of field. So relax, do not go anywhere, I'll be right back. You are welcome back to my school YouTube channel. Like I said earlier, we shall be learning about the description of field. But before we begin with our lesson, let's quickly run through the objective for today's video lesson. Objective number 1, explain the concept of force fields. 2, identify force fields from a set of forces. 3, identify the properties of fields, gravitational and magnetic. 4, explain why two bodies of different masses, when released from rest at the same point simultaneously, fall to the ground at the same time. Then the last but not the least, define the magnetic lines of force. So let us begin with our lesson. We will start this lesson by simply defining what field is. Okay, so field is a region or space under the influence of some physical agency such as gravitation, magnetism and electricity. So field is the same as force field. So now let's move on to talk about the classes of field. So we have two classes of field, namely scalar field and vector field. But you must not confuse this with scalar quantities and vector quantities. Though the definitions are the same, but they are two different concepts in physics. Okay? So a scalar field is one that has only magnitude and no direction. An example is work, heat, and pressure, etc. While a vector field is one that has both magnitude, of course, magnitude there represents size, so it has both magnitude and direction. An example is gravitational field, magnetic field, and electric field. Right now, let's talk about gravitational field. So gravitational field is a region or space around a mass in which gravitational force of the mass can be felt. So objects on or around the surface of the earth are always attracted or pulled towards the center of the earth by the earth's gravitational field. For this reason, the following observations are common. So let's see the observations by moving to the next slide. So one of them is that if you release an object in your hand, it falls towards the earth. 2, if you throw an object upward, it will move up to a point, gets to its highest point, then it will stop momentarily and fall back to the earth. Then 3, if you are lifting a bucket of water, you feel that a force is pulling it toward the earth. Then 4, there is a limit of height to which we can jump. Okay, when you are lifting a load, the force that pulls it towards the earth is the weight of the load. So the weight of an object is a measure of the earth's gravitational force on that object. This gravitational force causes a change in velocity of the object under its influence, meaning that it accelerates such objects. The acceleration of objects due to the Earth's gravitational force of attraction is called acceleration due to gravity. So here essentially we are saying that acceleration due to gravity is the acceleration of an object due to the Earth's gravitational force of attraction. Okay, so it is represented by the symbol G, small letter G, and it has an average value of 9.8 meter per second square. Let's move to the next slide. However, for simplicity of calculations, we usually adopt an approximate value of 10 meter per second square. The acceleration due to gravity is uniform for a given location and is the same for all bodies within the same location irrespective of their masses. It, however, varies from place to place on or around the Earth's surface. It decreases with distance of the object from the center of the Earth, that is, the closer the distance from the center of the earth, the more the value of its acceleration due to gravity. And the further the distance of an object from the center of the earth, the lesser the value of its acceleration due to gravity. Now, take note that the earth is not a perfect sphere, okay, in the sense that it is flattened at both the north and south poles. Thus, the axis of the equator is longer than the axis of the poles. So let's move to the next slide so that we can see a diagram representing the earth. So this is a schematic diagram of the earth showing objects at different locations. So these are the poles, the north and the south poles, and this is the axis of the equator. So from this diagram, you can see that the distance from the pole to the center of the earth is shorter when compared to the distance of the equator from this point to the center of the earth. So the diagram above is a schematic diagram of the earth showing objects at different locations on and around the earth's surface. Considering objects D, A, and E on the earth's surface. D at the pole is closest to the center O of the earth and has the highest values of G, followed by A, while E at the equator is the farthest from the center O of the earth and has the least value of G. Also considering objects A, B, and C around the surface of the earth and at varying distance from the center of the earth. So let's move to the next slide. A is closest to O with the highest value of G, followed by B, and C is the farthest from O with the least value of G. So basically, what we are trying to illustrate here is that we are just saying that the closer an object is to the center of the earth, the more the value of its center of gravity. So basically, that is what that diagram and the explanation under it is talking about. So the weight W of an object is the product of its mass M and acceleration due to gravity G. So mathematically, weight is equals to M times G, where M stands for the mass of the object and G stands for acceleration due to gravity. Now take note that mass is constant. So anywhere, okay, on the surface of the earth, mass is constant, but weight varies from one place to another. And this is because it depends on acceleration due to gravity. And acceleration due to gravity varies from place to place. Okay, so the acceleration due to gravity is also called acceleration of free fall. So the same definition for acceleration due to gravity, you can also use it for acceleration of free fall. That is, all objects falling freely falls with this acceleration. In the absence of air resistance or friction, all bodies fall with the same acceleration irrespective of their masses. That is, two bodies of different masses released simultaneously from the same height reaches the ground at the same time. So this is where we bring the preview of today's video to a close. But you can watch the complete video by simply clicking on the link in the description below, and that will take you to my school website. There you will need to subscribe to enjoy the complete video. So in the complete video, you will learn about magnetic field, magnetic substances and non-magnetic substances. You will also learn about magnetic flux and their properties and many more. There are also work examples just to drive home the lesson. So I believe you enjoyed this video. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.